We skipped over 12.4 because it was not needed for your use in Cal 2. But the binomial theorem is utilized in all facets of finding particular terms in a section, and it was included by the department as a necessity. And first off, we have to understand that binomial means two terms. So we've got some x and plus something, or y or z plus whatever. Two terms, it's what it means. And in this theorem, we're talking about Pascal's triangle. In Pascal's triangle, he starts with nothing, two terms, two, three, one. Okay, and there are ones all the way down, and it was kind of a tree. And what you would do would say, okay, if I have a binomial, it is the square of the first term twice their inner product plus square of the last. If it's a triple, it's cube of the first term square 3 times the product plus 3 times the product to the x, and then square cube the last term. All descending order. So this is x plus 1 squared. This is x plus 1 cubed. Okay, now, and it went on and on. But the problem is we could have a coefficient in the first term and a different number than 1 on the last term. So what do you do then? So this binomial theorem is counting principle. Counting principles are what we did at the beginning, which was a permutation, which was a factorial. Well, these are combinations. How many patterns can we get for each of the terms as we go forward? Understanding that the combination is starting at 0, then 1, 2, until you get to the exponential you need. So in this case, we talk about n over j. It's a combination quantity of how many parts we could have of the same value in a set. So if I have a set, and I have hearts and clubs and spades and diamonds. Okay, this is my set. Well, I'm seeing how many of that proportion. If I have none used, I'd have one set. So that if I had 4 and none, I would have 1 that I could do, none. And then if I had 4 out of 2 of them used, the second part, well, then I would have that quantity of how many 2s I could have. I could have heart and club, heart and spade, heart and so on. I'd have 6. All right, and so on and so on. And we could do this all the way. And then when I get to the end, which was 4, choose 4, I'd only get 1 again. If I have 1, I'd have the 4. Okay, here we go. Does everybody understand? So we're talking a finite set here, and this is going to be, and this part here refers to exponent degree of the binomial. That's very critical that you understand that. We're talking the degree of that exponential, the binomial raised to an exponential, is the degree of the entire thing. That is the n. All right. and the J is the term location. Now, there's more to this, by the way. They do these incredible multiplications of these things in tableau form. It's a tableau, a set of things that could happen. All right. And that's also a mathematical process that we are not going to cover. And that's pretty fascinating as well. So, like I said, n of 0 is 1, n of 1 is n, because there's n possibilities of singular use. N of n over n minus 1 is an n, and then n over n is again 1. We notice the start and the finish are 1s. The start and the finish are 1. Always. Better?
Yeah.
Thank you. Yes. Okay. It's all a pattern, and we're going to do it by calculator, so everybody relax. We're going to do all of this math. So then it says, if j and n are integers, which it has to be, between 0 and n, which means infinity, the symbol n over j is defined as n factorial over j factorial, n minus j factorial, which this is the formula for combinations. Formula for combinations. And we know it as NCR. I know, right? NCR. How many combinations of size R? And size is the location of the term of the binomial that you're looking for. All right, here we go. So first we're going to evaluate. We're evaluating how many combinations. All right, so we're going to be using our calculator. We're going to understand that this is the n and that is the j. So we're going to enter the the n value on home screen. Then we're going to give it a command. We're going to go to the math key, arrow over to probability, P-R-O-B, and we're going to choose number 3, NCR, and then enter the J value. And then hit enter for answer. You're only going to get a whole number. All right. Has everybody got that? Everybody write that down? Go under menu and look for probability. No. Keep going. Let me show you how mine is, because it's got to be like mine, even though, okay, on math and probability, once you get to probability, random, R-A-N-D, NPR is number 2, and number 3 is NCR.
Yeah, number in the bottom normal samples.
And it doesn't have any more? It won't scroll down? Are you sure?
Mm-hmm.
It has everything.
I know this thing has everything, it's just in a different spot.
Maybe it's under binomial. Random binomial. No. Oh, you know what? I'm going to send you. The catalog on it.
Probability, right?
No, stats. Let's see.
Stats?
Let's see if we can find it on stats. No. No, it had to be probability.
Mm-hmm. So there's your.
Oh, there it is. Combinations. Right there. Okay.
Yeah.
Combinations. And it comes, there it is.
Oh.
Good.
Let me write that down.
Okay. All right. Let me go back to my home screen. All right. Now remember, it's in first. Then you're going to go to the math key and go to prob and go number 3 and then enter the other. All right. Here we go. I'm going to enter the 6, hit my math key, go to PROB, go number 3. That gives me the command. And I'm going to enter 3 and enter 20. Did everyone get 20? That would be the coefficient to whatever the x or the last number is or whatever. Okay? Does everybody understand? Okay. So let's do the next one. Remember, this is my n and my j. So I'm going to have my 9, and then I'm going to hit the math key, arrow over to prob, and choose number 3. NCR, okay? And then hit the 7. Here we go. So I'm going to have the 9, math key, PROB, number 3, and hit 7, and then hit enter. Did everyone get 36? Okay, now this guy right here is one less, so we would have only 43 possibles. So we're going to do this one. 44, I'm sorry, I'm going to have 44 possibles. Sorry about that. Math, PROB, number 3, and hit 43, and we should have 44. All right, very good. Okay, now here, let me put the calculator down. On this guy right here, is the binomial theorem. Notice that it has n over 0, 1, so forth, till we get to our j, the last one in that exponential. This is in reference to a binomial, raised to that j. All right. So in this case, to the n minus j, sorry. This is 5. So my n is 5. And they expand the expression using the binomial theorem. So we're going to do it by hand because it's only 5, well, actually 6 terms. So this means, now remember, this is my x of n, and this is my a. All right, that's my a. All right, so we would write 5 over 0 for our first term. X to the 5, a to the 0. Anything to the 0 is 1. That's why they put just x. Plus 5 to 1, 1 less. That's going to give me x to the 4, and my a is 2 to the 1. Is that good? All right. My next term is still 5, and it's our third term in our list. X to the 3, 2 to the 2. Notice that this is here for the 2. This, and the first one was 0. The first one was for the x, and the next one is for the value. Then we have 5 to 3, and then we have x to the 2. What's 2 to? 3. These two add up to 5. Everything adds up to 5. Does everybody see it? Does everybody see that? Okay, all right. Now I'm going to do here. This is 5 to 4. This means I have an x to the 1 times 2 to the 4. And then I'm going to have 5 to the 5, and that's going to be x to the 0 and 2 to the 5. All right, now we're going to do the math. Now we know this is 1 and this is 1. Does everybody understand that? Yes. Okay, so I'm going to have x to the 5th plus. Now we know 5 and 1, we've got 5. Okay. 5 x to the 4 times the 2. All right. Now we have this guy. Now, I'm not always confident on, whatever that one is, so I'm going to do it. Is that okay? And then on the second one, I'm going to just take a second shortcut, but this is okay. 5 math, P-R-O-B, and I'm going to do a 2. Oops, sorry. Let me clear that. Oh, I forgot to put the 2. No wonder. Okay. 5 went too fast. Sorry about that. And I'm going to enter my 2. Okay. And I'm going to get 10. So that guy is 10 x to the 3rd, and 2 squared is 4. Is everybody good? Everybody breathing? Okay. Now I'm going to do the next one. I'm going to do second entry, and I'm going to just change the 2 to a 3. And I get 10. X to the 2 times 2 to the 3 is 8. Is everybody good? Now I'm 5 to the 4. So I'm going to do second entry, go back and change it to a 4, and I'm going to get 5. X, and this is 2 to the 4 is 16. And then my last one is 2 to the 5, which is 32. All right, now I'm not done. Now I'm going to tell you what this guy looks like. We have x to the 5th plus 10 x to the 4 plus 40 x to the 3rd plus 80 x squared plus 5, and what is that? Is that 80? Yep. Plus 80x plus 32. There it is. You've done all of that multiplication easily. Instead of doing the square, then times the next one, times the next one, and times. So that's pretty awesome. Is everybody comfortable with that?
So what's the factor into this?
Yes, it's a scaffolding.
Okay.
Each floor that we go up a degree, or go down a degree rather, it's a scaffolding. How about that? That's it. This is what you would enter in. Okay, and you're going to just take your time. There's any questions on what I did? I know. It's just, and it's so fun because you can do these complex binomials so easily. Now, what's the rub here? We got a 5 and a P. A 5P, and my A is 3. Is everybody ready? So, not everything is clean cut. We're going to do this. So here I go. I need more space. So I'm going to have 4 to 0. Thank goodness it's only 4. 4, 0, which is 1. 5p to the 4. And I don't have an a because it's a to the 0. Is that okay? All right. Plus 4, 1. And this is the 5p to the 3, right? And times 3 to the 1, because that makes 4. Has everybody got the 4 up there? All right. Plus 4, 2, 5p squared, and 3 squared. Is everybody okay? All right. Plus 4, 3, 5p to the 3, 3 to the 3. Does everybody see? Sorry about that. What did I do here? 3, 2, oh, this is p. Sorry about that. That's p. I apologize. Plus 4, 4, which is 1, and I'm going to have 3 to the 4 because I have p to the 0. Is everybody comfortable? Now we're going to take that shortcut I told you about. Here we go with the calculator. I'm going to clear everything out. I'm sorry, clear. Here we go. We're going to do the combination and any exponent. The first one is easy. It is what? 5p to the 4. The second one, we know this is 4, right? Times 3 times 5. Ready? All of the numbers multiplied. All right, now we're going to do this guy. 4, math, P-R-O-B, number 3, and this guy is 2. Okay, now I'm going to go side arrow and hit times 5 times 3 squared. And I get 270. Because I did that one. All right? Everybody see what I did? I did my combination times the 5, which is a coefficient of p, times the 3 squared. All right. So now I'm going to do, now I could do second entry and change it. All right? Okay. So I'm going to go back all the way over here and change this to a 3 and this to a 3. And then my last one is 3 to the 4, which I think is 81, but who knows. Everybody good? Okay, now this is what the computer wants. Now, what if we want a specific term? What if we want a specific term? So in using the binomial, they said n over n minus j, which is the term that we want. But we have to understand that we start with 0, right? So our set of terms, 0, 1, 2, 3, and this guy is all the way to 7, all right? So 0 means I take 1 away from the nth term listed, okay? In other words, if I had this guy right here, this is the first term, n minus 1, because it was a 0. This is the second term, right? So n minus that other 2, and so on and so on. So our terms are minus 1. If they want the fifth, then it's 5 minus 1, the fourth. Because 0 is one of them on the production. Okay, so we're going to have our 7, how many? And we want 4. All right. So that means that I would write x to the 4 and 2 to the, I'm sorry, x to the 3, sorry. to the 4. Because we'd have to subtract 1 as to where the term is, the 5th term. I know it sounds weird, but that's what we would have. And we would stick in those numbers. And I would go 7, math, PROB, number 3, and write 4. And then I'd multiply that by 2 to the 4. Is everybody comfortable with that? Not hard. But that gives you the specific term. If we looked at what we did before, all right? Now look at this one, 5. If we wanted the 4th term, 1, 2, 3, 4, it was this guy. And notice it's a 3. It's 1 less. Everybody cool? All right. And that was, I think that, I didn't do any more. I think that's all I did, isn't it? Yeah. And you've got about 2 of these. Got 2 of these. This guy here, you've got 4. It's very easy. And then you've got about 5 of these. Is everybody comfortable? All right. Is all good? Everybody know how to do the calculator? Oh, it's all calculated. Everybody good? All right.